So this question from 1999 looks it's an electrolysis question that looks a bit technical, but it's simple when you get to look at it. So it said when a current I was passed through an electrolyte solution for 40 minutes, a mass x gram of a univalent metal, univalent there means it has a charge of 1, was deposited at the cathode. What mass of the metal will be deposited when a current of 2I is passed through the solution for 10 minutes? So if you look at the question is relating two different scenarios. At first, it said a current of I. The first scenario, the first case, is that a current of I, the current is I, was passed for a time of 40 minutes, and the mass deposited was x gram. And then at the second scenario, we're having a current of 2I that is being passed for a time of 10 minutes. And then you are being asked, we're being asked what the mass will be. So what we just need to know is the Faraday's first law of electrolysis. So Faraday's first law of electrolysis told us that mass deposited is directly proportional to quantity of electricity. Now we know that quantity of electricity is equal to what? IT. So we can easily say, which is current times time. We can easily say mass is directly proportional to IT. So we can also say that M is equal to, so we introduce a constant. You can use E right here, IT. Let's make the constant the subject of the formula. Making the constant the subject, E will be equal to M, which is mass, all over IT. Now, since we have more than one case scenario, that's one case, we will now say E is equal to M1 all over I1 T1, which is equal to M2 all over I2 T2. So we could use here, right here, to solve the question above. So let's substitute. So for the first case scenario, the mass deposited was x grams. So we could say x all over. The current used was just I, and the time used was 40. But we can't say 40 minutes because we have to change to seconds. So we'll say 40 times 60, which is equal to, we're looking for the mass in the second case all over. The current used this time was 2I times 10 minutes, which will change to seconds by using times 60. So would have mass is equal to x times 2I times 600 all over I times 2,400. So these two zeros, take care of these two zeros. This I cancels this I, and right, would have 6 cancelling this to give us 4, and 2 here 1, 2 here 2. So our mass will be equal to x all over 2 gram. So I think that is the mass will be x over 2 gram, and that is option B. Option B. Yeah.